Okay, I'm going to pass this sheet around. If you don't have the extra review completed to retake a test, you can still put your name that you want to retake a test. But remember, I do have extra stuff that's at the bottom of my math lab that you're supposed to do in order to retake a test. Our retake test day is next Tuesday. So you can put your name on it, even if if you're interested in all retaking a test. I gotta make coffee. Okay, so what we're going to do is cover section 6.6, and then we're going to, if we have time, we'll talk about that homework that you've had to review worksheet 6.3 and 6.6. It's not due until next time. Now, why did that get darker when I said the lights? Okay, probably need to. Okay, so, all right, so vectors. So we're covering vectors now. Vectors involve both a magnitude and a direction. Scalars involve magnitude, but no direction. So we've got some definitions. A directed line segment is a line segment to which a direction has been assigned. P is the initial point, and Q is the terminal point. And it's denoted by PQ with an arrow over it. The initial point first, the terminal point second. The magnitude of a directed line segment is its length, which is denoted by, this is the 2 bars, put PQ, that means magnitude, 2 bars around it. A vector is a directed line segment. So those are the definitions. We got some more. Can you see all that? Okay, so let's walk in. All right, vectors are equal. That's right, Taylor. I agree. Vectors are equal if they have the same magnitude and the same direction. We're going to use the distance formula to show vectors have the same magnitude. That means magnitude. One way to show vectors, actually the distance formula doesn't fit in there. I think that's what's put in there. distance formula was the square root of x2 minus x1 squared plus y2 minus y1 squared. One way to show vectors of the same direction is to find the slope of the lines in which they lie. So if you find the slope, and that formula was m equals y2 minus y1 over x2 minus x1. So here's an example of some vectors. If it's written in boldface, that means it's a vector. If you're writing it on paper, we'll put the little arrow over it. When you're writing them, so in my notes I've been putting the arrows over it because it's hard to tell boldface from regular. But your textbook does boldface, and that means it's a vector. Okay, so this is page 741, and there's extra examples, but this is checkpoint 1 in your book. So we're gonna show that these two vectors are equal, that they have the same magnitude and the same direction. That's what we're trying to do. Show U and B are equal. So we're going to find the magnitude using the distance formula. So I used, this is x1, x2, it doesn't matter, x1, y2, okay. I use these as 0.1 and these as 0.2, but it doesn't matter. When you square them, you're going to get positive numbers. So the magnitude of U equals the square root of, I can do it this way, it doesn't matter. X2 is -5 minus x1 is -2 squared plus the square root of y2, no, not the square root, sorry, y2 minus 6 squared. Okay. I should have done it a little further down. In my notes I did it the opposite way, so I guess. Okay, -5 minus a -2 is plus 2. -5 plus 2 is -3. And 2 minus 6 is -4. When you square these negative numbers, you're going to get positives. So you get 9 plus 16. And that's the square root of 25, and that equals 5. All right, the magnitude of V. So you don't separate these with a plus sign. You can't do that. Add them, take the square root. All right, the magnitude of B is the square root. Okay, I use this is x2, y2 in my notes, my filled-in notes. Okay, so it's x2 5 minus x1 is 2. We've got a minus sign and then a plus sign here, and then 6 minus 2 squared. So that square root of 3 squared plus 4 squared is square root of 9 plus 16 is the square root of 25, which equals 5. So the magnitudes are equal. Now we need to show that the slopes are equal. We better use the same setup for slopes. We've got it. This has got to be x1, y1, x2, y2. We've got to have them defined the same way: initial point, terminal point. So for magnitudes it didn't matter, but for slope it's going to matter which way I had that defined. So we got to start then with, we got to find the slope. So the slope of v of u is y2 minus y1, x2 minus x1. So because we're not just finding the slope of a line, we're finding the slope of a vector, we had to define the point 1 and 2 the same way. So it's best to start with the initial point as 1 and the terminal point as 2. Plugging in 6 minus 2 over okay, and then over minus 2 minus -5. So that's 4 over, this is minus and negative, it's plus plus. So that's 4 over -3. Positive 3? Oh, positive 3, yes. Thank you. Okay. -2 plus 5 is positive 3. So the slope of u is 4/3. What's the slope of b? M of b is, okay, 6 minus 2 change in y divided by the change in x, 5 minus 2. That's 4/3. So they're equal. Okay, so we find the magnitude, we find the direction, with the slope. We've got to define the points the same way. Okay, scalar, we got some more definitions. There's a lot of definitions. Scalar multiplication is multiplying a real number k and a vector v. I just go ahead and put the arrow over it. It is written as kv, because we can't do boldface. Okay, so this is a lot of definitions. I've got those Quizlets out there for this. Multiplying a vector by a positive real number, except one, changes the magnitude of the vector, but not its direction. Multiplying a vector by any negative number reverses the direction. And this is page 741 in your book. Okay. So more definitions. So if k is a real number and v a vector, the vector kv is called a scalar multiple of the vector v. The vector kv has a magnitude of the absolute value of k, which was a real number, times the magnitude of v. That's how we show that. We describe this as the absolute value of k times the magnitude of vector v. There's the symbol for it. Here's what it means. The vector kv has a direction that is the same as the direction of v if, we just said this up here, if k is positive, greater than 0, or a direction that's opposite the direction of v if k is negative, less than 0. We just said that, 0.6. Okay. The sum of u and v, denoted by u plus v, is called the resultant vector. To add these two vectors, position the vector so that the terminal point of u coincides with the initial point of v. Sketch this. So I'm going to show you this. If this is u, here's the initial point of u, terminal point. And then if this is v, then this is the vector u plus v. So the terminal point of u matches with the initial point of v, and so you could figure out the sum of those graphically. Okay. And we'll do a difference. The difference, v, vector v minus vector u, is defined as v minus u. You can rewrite that as adding the opposite of vector u. It's v plus the opposite of vector u. So we can do a sketch of that. Let's see. So I'm going to make u here. And so negative u would be here. Vector b if this is vector b, we have to put it over here instead. We have to put it at the terminal point of negative u. And then we're going to go here. Then this is the vector b minus u in blue. So I'm sure that this is page 742. I'm sure there's a nice sketch in the book. You can see the colors if you're looking at my screen. You can kind of see it here. Okay, and then we need to define a unit vector. A unit vector has a magnitude of 1. Vector I, we usually write that as small I. I don't know why it's capitalized, but it's small I. Is the unit vector along the positive x-axis. And vector j is the unit vector along the positive y-axis. So now their definition, a unit vector, it has a magnitude of 1. So we have vectors along, I is a vector along the positive x-axis, j is the positive y-axis. So if I want, so I, j, that's one unit. This may not take long if we don't have too many examples. So get used to all these terms though, but since this is take home, you don't have to memorize that stuff. But you'll need to know some of it for the final. I will have your take-home test for you Wednesday to hand out at the end of class, and bring it back by Monday. No, Thursday. Thursday. Okay, sorry. Yeah. Well, just kidding. Are you awake? I'm not. Okay. I always get messed up with these days. Okay, we're a Tuesday-Thursday class, so I'll have it Thursday and give it back by Tuesday at the beginning of class. Okay, got it right now. And I'll put an email and announcement about it. So be sure to come to class Thursday. All right. More definitions. Okay. More information here. Yes, definitions. Vector v, if you draw vector v from the origin to the point AB, you can represent it with these unit vectors by v equals a times the vector I, the unit vector I, plus b times the unit vector j. The real numbers, a and b, are called the scalar components of b. with A being the horizontal component, and B is the vertical component. The vector sum AI plus BJ is called a linear combination. And the magnitude of the vector B defined this way is the square root of A squared plus B squared. So we'll draw a sketch. These are our axes. This is A. So we've got a vector here, A times the unit vector I, and then we've got a vector B times J, and that's going to equal your vector B. It's going to go from here to here. This is B. That's vector B. All we're talking about is there. Can you see that? It's all right. So it's in your book around page 742-3. Okay, so we're going to sketch this vector and find its magnitude. This is page 743, checkpoint 2. Okay. So we got 1, 2, 3, -1, -2, -3. So we have 3i here. And we've got to put, you've got to, you can put 3j here, but you've got to put, when you're, we're putting negative, we're rewriting this 3i plus a negative 3j. It's a j. Okay. So I'm going to draw negative 3j instead of positive 3j. This is negative 3j. And then we're going to add those. And this is the vector B. Find its magnitude. The magnitude of B. It's just the Pythagorean theorem. We've got a right angle here. Because they're unit vectors I and J, right angles. So that's the square root of A squared plus B squared. 3 squared plus negative 3 squared. And that is 9 plus 9, 18. And then you're going to simplify that by realizing 18 is 9 times 2. So that square root of 9 is 3, square root of 2. If I want an exact answer, and I usually do, I want it with the square root the square root in it. Okay. So, next thing, we have 4 definitions. Yeah, that's what this mostly is. All right. So vector V with an initial point P1 equals x1, y1, and terminal point P2 equals x2, y2 is equal to the position vector. So you need to know that the position vector has its origin, it starts at the origin. The initial point is at the origin. So we are just moving this vector that can be anywhere so that its initial point is going to be at the origin. So how do we do that? We take the vector V equals x2 minus x1 times I plus y2 minus y1 times j. Okay. So we're letting V be the vector from point 1, initial point, minus 1, 3. The terminal point, P2, is 2, 7. This is x1, y1, x2, y2. Write V in terms of I and j. This is this is page 744, checkpoint 3. Okay, so we're just going to use this formula. But you do need to identify, this is your point 1. The initial point has to be point 1. The terminal point has to be point 2. So V equals x2 minus x1, that's 2 minus a negative 1. I plus 7 minus 3 j. Then we change signs here. So we have 2 plus 1 is 3i, and 7 minus 3 is 4j. Caught up there. Okay, so that's not at the same place, but it's equal in magnitude and direction to this other vector. It'd probably be a good idea just to sketch that. I don't have, I guess I could do a quick sketch. So we got 1, 2, 3, 1, 2, 3, 4. So this is B. We probably should have called, this is the position vector. We probably should have called this another letter, but okay. Oh, the initial vector, what was that? -1, +3, and then 2, 7. That was up here. 7. So it's up here. And my sketch is kind of crude, but you can see those are equal if I had made the markings equal. Okay, so, all right, and then now we're going to be adding vectors. So if vector V and W are position vectors here, because they have, then we can add them. V plus W equals, you just add the scalars in front of I, the unit vector I, so it's A1 plus A2 I plus B1 plus B2 J. And then we want to define the subtraction of those is A1 minus A2 I plus B1 minus B2 J. Or you could have rewritten this as addition and used that formula. So you don't have to use the subtraction formula. All right, got that. Is this review for you guys, Becky? I don't know. All right, is everybody done? All right. We're on the last page, guys. So we'll do the have you do the preview worksheet in class after this. So we're going to do this last page. So this is page 745. Checkpoint 4. We've got vector V is 7I plus 3J, and vector W is 4I minus 5J. Find V plus W. We're going to take we could treat this as like terms. 7 plus 4I plus 3 minus 5J. And that's 11I minus 2J. Subtracting those, you're going to take 7 minus 4I plus 3 minus a negative 5J. Change these signs. You get 3I plus 8J. Okay, 17. If B, vector B is AI plus BJ, and K is a real number, then K times B equals K times A I plus K times B J. Multiplying a scalar times a position vector. So the next one, this is checkpoint 5. Find A times B. B is this. So that's 8 times 7, I plus 8 times 10, J is 56, I plus 80, J. We're just distributing the 8. Negative 5, B is negative 5 times 7, I minus 5 times 10, J. Minus 35, I minus 50, J. Okay, page 746. The vector whose magnitude is 0 is called the zero vector. Okay, I'll talk about vector. What's your vector? Anybody see your? What's your vector? Oh, has anybody seen the movie Airplane? It's kind of dating myself. It's called the zero vector and can be written as 0, and you can write it as 0 times I plus 0 times J. The unit vector for any non-zero vector, V, is V divided by its magnitude. So anytime you want to find a unit vector for a non-zero vector, remember a unit vector has a magnitude of 1. So when you take the vector V and divide it by its magnitude, you get a magnitude of 1. Checkpoint 7, find the unit vector in the same direction as V equals 4I minus 3J. Then verify that it has a magnitude of 1. So we're going to find the magnitude of V is the square root of 4 squared plus 3 squared. You know, it's negative 3 squared, which will be positive 3 squared. Is 16 plus 9 is 25. So the magnitude is 5. Okay, so we're going to divide this vector V by 5. So we're going to divide each term by 5. We get 4/5 I plus minus 3/5 J. So this is the unit vector with a magnitude of 1. Now you can check that that has a magnitude of 1, and I squeezed it in over here. We take the square root of 4/5 squared plus 3/5 squared. Well, you know, there's a negative 3, but we can put the negative there. So that is the square root of 16 over 25 plus 9 over 25. That's the square root of 25 over 25 is the square root of 1 is 1. So we just checked that that magnitude was 1. And there really wasn't an effort for that. Okay, and then we can express a vector in terms of its magnitude and direction. Also, you can do this way. A vector v is the magnitude of v times the cosine of theta, where that's the cosine of, well, I can draw it, but in a second. I plus the magnitude of v times sine theta j. Okay, so if I get some paper here, if I draw a picture, what we're talking about. So you've got a vector here, v. This is just, you can, and this will be the AI plus bj. So A, we know this is theta. So how can we find theta? How can we find A? Cosine of theta equals adjacent over equals A over the hypotenuse, the magnitude of V. Solve for A, you multiply by the magnitude of V, and you get A equals magnitude of V times cosine theta. We're just using our trig that we learned earlier, and you can do the same thing with sine. Sine of theta will be opposite over the magnitude of the vector. Will be b over the magnitude of b. And when you solve for b, you get what we got there. So one more example. Get that? Some people are still writing, so I gotta slow me down if I'm going too fast.
On the test, are we going to put the errors above like I's and J's and the A's and B's?
Yes, not above the A's and B's, but above the I's, J's, any vectors, you should put the arrows.
Okay.
Because I don't think you can do bold print with your estimate. So. Okay, good question. All right. So here's an example. The jet stream is blowing at 60 miles per hour in the direction of 45 degrees east of north. So, what do they mean? It's blowing at 60 miles an hour F. So this is 60, and it's 45 degrees east of north. That's what we've got. So there's our vector. Well then, if this is 45, then this is also 45. And so we got that angle. They want us to express this in terms of I and J. So they want us to write it. So we're going to use this formula. We could derive the formula again. We don't need to. Okay. So the magnitude of V is given to us as 60. We need to find the cosine of theta. If you look at your unit circle, the cosine of 45 degrees is square root of 2 over 2. And then we're going to need the sine of theta. Well, that's also square root of 2 over 2. So V equals the magnitude of it, 60, times cosine theta is square root of 2 over 2 times I, plus the magnitude of V is 60, and then times sine theta, well that's square root of 2 over 2. So I'm just substituting right into this equation. J. And then we simplify that, and we get 30 square root of 2I plus 30 square root of 2J. So we're going to be using our unit circles and giving the exact numbers for 30. Just substitute it right in there, okay? Any questions? All right, so we got some time to work on (3.3) and 3.6 preview, or 6.6. So you guys can, if you've already done it. So this is that preview worksheet. 6.6 and 6.3. 6.6. 6.3 and 6.3. You will need to convert R equals 5 to a rectangular equation. And then they have a problem number 2 with vectors. I haven't worked out, so you can spend a little time working on this. And you talk to each other about it. You want to write the vector V. Here we're given the vector V has magnitude of 35, and the angle it makes with the positive x-axis is theta equals 200 degrees. We want to rewrite that as V equals V1I plus V2J. So that's, if you don't want to print, if you don't have printing money, you can simply write these equations out, right? And I'll walk around and answer questions. If you want to print it, you can. So maybe I should pull up the notes from 6.3. Converting from polar to rectangular. It depends if you're doing a point or we're doing an equation. This is an equation. So here was section 6.3 notes. Says when you convert from polar equation from polar to rectangular, use one or more of the following equations. Sometimes it's necessary to square both sides, take the tangent of both sides, use an identity, or multiply both sides by r. What?
It's an R cosine thing.
Equals x. Yeah, it's not very. So, this is how you do problem 1. You're going to figure out which of these you're going to do, and then use those equations. You got it. Alright, so most people are on the second one. And the second one's just like what we just did. Except you do need to notice that 200 degrees. What's the second one? Oh, sure. So that's how you do the first one. I think most people have that done. The second one is you got a vector v that has a magnitude of 35. Theta is 200 degrees. And you're going to rewrite it like this, but you're going to use the formula we just went over. So I'll write the formula down. The magnitude of v times cosine. Oh, I'm actually putting, I should have just put theta. A 200 plus the magnitude of v. Well, I'm already putting in the angle. You got to draw and make sure you get sine. Okay. You're going to use that formula for the second one. We just did that. And you're just going to, this is not a 30-degree angle or we're just going to use our calculator to find that cosine and sine. And round to 4 decimal places. So it's not at a 45, and it's not at a, we're not going to try to figure out the exact square roots. Because this is not one of our 30-60s or 200. 20 degrees more than 180, so that's not one of the angles that we could either use circle for. We're just going to use the calculator. You got it figured out, don't you? Almost. Yep, that's a good sketch. Good. It's a good idea to sketch it. Where is it? And if you finish that, did you finish this one? Yeah. Oh, no, you cannot combine those. This has got an I on it, and this is J. You put one step too far. It's gonna be, you can't combine them. They have an I and J. Stay like that. Okay? Good job. Did you finish with that? You're on work. You're just putting that. Is this one? Well, I've got the equation you're gonna use right there. Yep, the green one. You got a magnitude given to you of 35. You use your calculator to find cosine of 200. Make sure it's in degree mode. Multiply it by 35. That goes to the I. Okay. No, you won't. Hey.
The last one? Just put it in your hand.
Plus 35% of 200.
Did you finish that? Okay, good.
Where's mine?
It's not, you just make, you put the 30.
Right?
Oh, and then the I.
That's your circle. I mean,
God.
see my circle? Mine ended up being elliptical. Did you get the other one? Yeah. Good. And it's, you got the I and J. It's an arrow, not a carrot. It's like a carrot, but
Yeah.
okay. Good.
I'm not an artist.
You're not an artist? Okay. All right. So, remember next time there is a 2 quizzes. It's a quiz. We didn't cover 6, 7 yet. Is this one? Oh, you know what? We'll probably just do, is the second quiz on vectors, and does it have, oh no, it's fine. There's not a problem 3, by the way, on this quiz. Okay, you can do that. We'll look at it in a week. We'll cover 6, 7 next time. Where's my sheet where you guys are going to sign up for tests? This discussion thing? Oh, there it is, right here. So, by the now test one. Yeah. By now test one's pretty easy. Okay, this front row didn't get this sign up. Here are the answers to that, guys. I went to 4 places here, but it's okay if you went to 2. Okay, so you're going to square both sides in the first one. Who had a question? Oh, okay. Is it what? Well, if I ask you, I won't tell you what it is. So, it's okay if for this purpose, you do one. But if I ask for 4 on the second, really? I didn't know you were that old. All right. See you guys next time.